ask Chelsea to come up and give us our second presentation for the breakout groups.
So my name is Chelsea. I'm the ecosystem scientist with Parks Canada. I work in the climate population science team at Parks of National Office. And my work is mainly in providing climate change data and support to our and that's because I release as investors 150,000 under square area of Canada, among with some of our indigenous partners as well. I added this not just because, as we see the Northwest Territories, there's very large areas of NWT. At the bar, I mentioned 7% of NWT time was administered by FOSS Canada and our indigenous partners. So there's some very large areas, many different types of ecosystems that we are interested in. So I just want to talk a bit about how we're thinking about existing part of management across Canada. So everyone see Canada bets hard stores carbon net to affected ecosystems and increasing important global conservation goals way change. So protect, manage, restore, and enhance where appropriate ecosystem carbon to avoid our emissions where possible. And then when we're thinking about stewardship of ecosystem carbon, this requires that we understand the current distribution and dynamics of ecosystem carbon, so where it's at. It also involves understanding the status and trends of ecosystem carbon in light of climate change as well. And we're also working to develop guidance and best or beneficial practices to do things like plant development and operations to avoid impacts to store carbon and to also protect and restore ecosystems to better manage carbon over time. So I had some many wonderful speakers before me who introduced these concepts. Thank you especially to the Carbon 109 Farnell and Andrew. It was fantastic. So I'm just going to jump straight into this. I'm first going to focus in on forest carbon because those are the results we've released so far, and then I'll touch the other ecosystems at the end of the talk. So this is our forest carbon atlas. We published this in October 2023. Tara Sharma was the main instigator of all this work. She did the vast majority of this on day. I'm here basically presenting her work. And in this report, he modeled forest carbon stocks and focuses for 31 national parks for the period between 1990 and 2020. This was a multi-year collaboration with the Canadian Forest Service. And over that time period, he found that national parks stored 1,450 megatons of carbon, with a net gain or sink of around approximately 7 megatons of carbon over that 31-year period. If you're interested, the QR code goes to our report. And then we've also got a map of with buffalo on the walls as well. If you want to take a look at that and look at this kind of appreciate just a little bit. So I'm not going to go into this too much, but what we did is we used the Canadian Forest Service's generic carbon budget model. And Ellen touched on this. It's one of its models that simulates the flows of carbon between different pools. These pools are above ground biomass, below ground biomass, litter, dead wood, and soil organic carbon. And this model tracks carbon stocks in the transfers between these pools and many other carbon flux metrics. So again, there's a lot going on in this diagram, but the important parts are what this model does is outputs carbon stocks to fluxes, which are spatial and non-spatial, in the top right background box. And then if you look in this bottom left box, there's a number of spatial outputs that this model requires. And those include things like forest inventories, what are the weed species in that area? We include things like wildfire extent, prescribed birds, if there have been insect disturbance events, temperature data, harvest data that's for managed forests. And then some other key ones, which I think they're important in genomic context, are yield curves, which talk about how much biomass is being accrued over time to both trees, and then other parameters with species. In terms of selecting sites, we ended up choosing Southern Sites BA. And this is due to the availability of data, and that spoke in terms of the forest inventory data that was available. But this is also in terms of the yield curves. So the Canadian Forest Service has yield curves for different tree species. However, they are usually in a southern context and more related to managed forests. And so we were able to use yield curves that we thought accurate and was accurately assimilated the carbon in the ecosystems. So the northernmost park that began deducting this forest with Buffalo National Park as well present here. But we did assess carbon in 31 national parks across Canada. So everything apart from grasslands is Sable Island to the south. So this is that same map that's on the wall. In terms of the Buffalo National Park, this is showing total ecosystem for stocks. And And the different colors, darker red is higher stocks, and the green to blues are lower stocks. So this had the greatest carbon stocks of all parks assessed. It was one of 2 parks that showed decreases in carbon stocks over time due to disturbances. And this is mainly wildfire. So over 1.3 million hectare burnt between 2002 to 2020, or 2% a year. And this actually ended up with a net total GHG emissions, so a source of quite a fair amount of carbon from it kind of. I will note that this data is from Strategy 20, and we're actually updating it now. I got the email today with the updated data, so I wasn't sure who put its presentation. But that'll be is up, yeah, to this data. And that'll be up to 2023. So that should include some of the larger fire years you recently, right? So in terms of emissions, that was stocks. For emissions, we did look at collectively across the entire parks that were assessed with all 31. And there's a lot going on here, but in terms of the graph on the right, in the orange bars are wildfire area disturbed. And then the green is looking at annual and cumulative GHG emissions. If you're above the line, you're a source to the atmosphere, so you're releasing or emitting greenhouse gases. If you're below, you're a sink, so you're absorbing the atmosphere. And so what we found is that there was actually large-scale wildfire in just a few parks, with Buffalo being one of them, but dominated the carbon dynamics and greenhouse gas emissions at the national level. Disturbances from the insect outbreaks and prescribed fire led to minor GHG emissions. But as you can see, over time, we collectively became a source of greenhouse gas emissions. And this is largely due to fires in 3 parks with Buffalo, Barton, and Elk Island. So in terms of next steps for explorers carbon, we have this updated data that's coming. But one of the things that we're looking to do, and I'll live and talk, you will hear about that as well, is trying to use more northern appropriate yield curves and looking for park scale inventory data for our large national parks across the north, particularly in NWT. So if you look at this graph here, it's just looking at our total stocks, and I pulled out with Buffalo National Park and then all other Gertie parks combined. So you can see that there's a lot of carbon in these northern parks. So if we added in Cho or Nahanni, for example, I can imagine that they would have as watches with Buffalo as well. The other thing that we are looking at is looking at Bikushi and machines, so trying to project these forwards. This is looking at the past couple decades, but we're really interested in how climate change might impact this. And then the other main question, which I grew up cracking with, is how do we manage for carbon in the future, increase frequency, severity, size of wildfires? So in terms of carbon and other ecosystems, I'll just touch on this really briefly. So I'm leading a project with 2 researchers from University of Alberta and University of Saskatchewan. We're looking at modeling carbon in 4 prairie national parks in grassland areas specifically. So that's one project that's ongoing, started this year. In terms of blue carbon, my colleague Marla Blad has been working at modeling eelgrass and salt marshes in a couple of coastal parks. And in terms of peatlands, this is something I'll touch on in the next slide, but we have a fairly large peatland project that's going on that's looking at mapping peatlands across a number of peatland parks. So in terms of peatland parks sampling other national parks, we have a partnership with UCAM, which is a project that's led by my colleague Allison Cassidy. And we're trying to quantify carbon stocks in peatlands in national parks. This is particularly important, for example, for Wood Buffalo, because you've seen the forest carbon atlas results from this, but one thing to keep in mind is that 30% of that part is also carbon in peatlands. And so we're vastly underestimating the amount of carbon stored in the below ground from those areas. So what we've been doing is looking at collecting peat depths and quarries from 6 national parks so far, mainly in the Atlantic this last summer. And that's also including from Permafrost, peatlands, and Buckbush and Sheepdrift. And we're also working with partners to quantify carbon fluxes using the Canadian module for peatlands, And we're looking at working on including a module for Permafrost, again, led by my colleague Allison Cassidy. And there's probably many others on this call that are also working on that pipeline as well. And then finally, this coming summer, we're looking to sample in a few different parks in the West, including New Buffalo National Parks. We're hoping to fill in some of those gaps for carbon in our peatland areas. And that's something we're talking currently with parks staff and with our partners to be able to try to place for this summer. So in terms of next steps, what we're interested in doing is developing a site-level story landscape carbon for different parks. So on the right, you have an example from Ujak National Park in New Brunswick, where we've added in forested areas in green, we've added in peatland areas in Hahal, and then also blue carbon areas for salt marshes. Um, we're hoping that these maps will help to inform management decisions, including with respect to park zoning, asset or infrastructure development, ecological restoration, potentially boundaries of new parks, and also to tell the story of what is carbon and why is important to our considers. And that's it. So, yeah, thanks very much for your attention.